Picture this: you are standing on the edge of a bottomless abyss where time stretches to infinity, and the very fabric of existence unravels before your eyes. This is not science fiction. It is the terrifying reality of a black hole, one of the countless dangers lurking in the vast, unforgiving expanse of the universe. Out there, in the endless stretches of space, danger comes in unimaginable forms: stars that explode with the force of billions of nuclear bombs, planets cloaked in acid rain and crushing pressure, or regions so desolate and empty they seem to defy logic itself. The universe is not just a place of wonder and beauty, it is a realm of extremes that challenge the limits of our understanding. Today, we will journey through 10 of the most perilous places ever discovered in the cosmos, places where survival is not just improbable, but entirely impossible. From monstrous black holes swallowing entire suns to ghostly rogue planets wandering in eternal darkness, prepare to explore the science, mystery, and raw power behind these cosmic death traps. Are you ready to uncover just how terrifying the universe can truly be? Let us begin. Now, turning to the first destination on our journey through cosmic peril, we encounter the Boötes Void, an enormous and mysterious region that defies conventional understanding of the universe. A cosmic void is essentially a vast area of space with an unusually low number of galaxies, but the Boötes Void is no ordinary void. Stretching an astonishing 330 million light-years across, it is one of the largest known voids in the universe, a realm so empty it is often referred to as the Great Nothing. To put this in perspective, the observable universe is teeming with galaxies, often clustered together in intricate webs, yet the Boötes Void harbors only a fraction of the galaxies typical for a region of its size. This unsettling emptiness leaves astronomers puzzled and somewhat unnerved. Some theories suggest it could have formed from the merging of smaller voids over billions of years, creating a sort of cosmic desert, while others propose even more speculative explanations, such as the influence of unknown cosmic phenomena. Its eerie vastness challenges our understanding of how matter is distributed throughout the universe and raises profound questions about the forces shaping these structures. The very existence of such a silent, desolate expanse prompts us to rethink our assumptions about the cosmos and what may lie hidden in its darkest corners. This is just the beginning of our journey through the universe's most dangerous and mysterious places, and already we are confronted with the unsettling reality that even nothingness can be profoundly intimidating. Moving forward, let us dive deeper into what makes the Boötes Void not just a mystery, but one of the most unnerving places known to humanity. Moving forward, let us delve deeper into the haunting implications of the Boötes Void, a place where the vast emptiness becomes not just a physical phenomenon but a psychological one. Imagine the striking contrast. Elsewhere in the universe, galaxies gather in magnificent clusters, interconnected by glowing filaments of gas and dark matter, forming what scientists call the cosmic web. These regions teem with activity, from stars being born to entire galaxies colliding. Yet here, in the Boötes Void, there is only silence. This desolate expanse disrupts the familiar rhythm of the cosmological dance, creating an eerie sense of isolation on an almost incomprehensible scale. For astronomers gazing into its depths, the loneliness it evokes is profound, as though the universe itself has paused and left a haunting void in its wake. The psychological impact of such emptiness challenges our understanding of existence. It reminds us that humanity, nestled within the relatively vibrant Milky Way galaxy, is surrounded by a cosmos that is far less forgiving and far more enigmatic. This sense of cosmic solitude weighs heavily on the imagination, raising unnerving questions about our place in the grand scheme of the universe. Could regions like the Boötes Void indicate that there are forces or events we are yet to comprehend, capable of carving out such immense pockets of nothingness? These are the questions that keep scientists awake at night, The Boötes Void is not merely a mystery of science, it is a confrontation with the limits of human understanding. And as we prepare to leave this vast, silent chasm behind, the unsettling possibilities it presents linger in our minds, setting the stage for the next chapter of our journey through the universe's most dangerous and awe-inspiring places. With the next phase of the journey in sight, we find ourselves venturing closer to home, to a place that is as mesmerizing as it is lethal, the center of the Milky Way galaxy. Here lies Sagittarius A*, a supermassive black hole with a staggering gravitational pull capable of ripping apart entire stars and devouring them whole. This chaotic heart of our galaxy is a region of extremes where the rules of physics that we rely on begin to stretch and break. Imagine a place where stars orbit at breakneck speeds, some slingshotting dangerously close to the black hole's event horizon, the point of no return. Radiation blankets this area, bombarding everything in its path with deadly energy. The environment is tumultuous, with violent bursts of light marking the catastrophic end of stars as they are shredded apart and consumed. However, the threats do not stop there. This is also a region of intense star formation, but even this process is fraught with danger. Newborn stars often find themselves in unstable orbits, their lifespans cut tragically short by the gravitational chaos around them. For any spacecraft daring to venture into this perilous zone, survival would be impossible. The extreme gravitational forces would stretch and crush it beyond recognition, while the high levels of radiation would render any onboard systems and life support instantly inoperable. This swirling maelstrom is a stark reminder of the violent forces at play in the universe, forces that can obliterate with unimaginable power. The center of our galaxy is not just a place of destruction, though it is also a place of profound mystery, a reminder of how little we truly understand about the cosmos. As we marvel at this deadly yet captivating region, we are compelled to ask, what other secrets lie hidden within the heart of our galaxy? As the next challenge unfolds, let us take a closer look at the supermassive black hole Sagittarius A*, and the ferocious process by which it consumes nearby matter. Picture this: anything that drifts too close, a wandering star, a cloud of gas, or even a planet, faces a terrifying fate as it is caught in the black hole's immense gravitational grip. Once captured, this matter spirals inward, forming what is known as an accretion disk, a swirling ring of superheated material that glows brightly as it is torn apart. The temperatures in this disk can reach millions of degrees, and the radiation it emits is so powerful that it could fry any nearby object long before it comes close to the event horizon. Beyond just consuming matter, Sagittarius A* also releases energy jets, streams of high-energy particles that blast outward at nearly the speed of light. These jets are among the most energetic phenomena in the universe, capable of wreaking havoc on anything unlucky enough to be in their path. To give you an idea of its immense scale, Sagittarius A* is estimated to be around 4 million times the mass of our Sun. The gravitational pull is so strong that even light cannot escape once it crosses the event horizon. A spaceship straying too close would be doomed, experiencing what scientists call spaghettification, being stretched into elongated shapes by the extreme difference in gravitational forces between its front and back. Any crew on board would not survive, as the intense radiation and crushing forces would destroy both the vessel and its inhabitants in seconds. Understanding the mechanics of this black hole offers a glimpse into just how destructive and powerful these cosmic objects can be. Yet, even in its destruction, it gives us a unique opportunity to study the most extreme conditions in the universe. Moving forward, we journey beyond our galaxy's core to uncover the hidden perils lurking in the far reaches of the cosmos. Now turning to the Eagle Nebula's breathtaking pillars of creation, these towering columns of gas and dust are nothing short of iconic in the realm of astronomy. Stretching light years in height, they represent the raw and untamed beauty of the cosmos, often associated with the birth of new stars. However, beneath their serene and picturesque exterior lies a much darker reality. These so-called pillars of creation are, in fact, rapidly being dismantled by intense radiation emitted from nearby young and energetic stars. This radiation, composed of high-energy ultraviolet and X-ray photons, acts like an invisible scalpel, gradually slicing away the edges of these vast cosmic structures. Over time, the very forces that foster star formation within the pillars are the same forces that will ultimately lead to their destruction. For any spacecraft daring enough to venture near, the environment would be utterly hostile. The sheer amount of radiation permeating this region could fry sensitive instruments and electronics in an instant. In addition, the charged particles carried on stellar winds from those nearby stars create an environment so aggressive that human survival would be impossible. Even with the most advanced shielding, the combination of heat, radiation, and particle bombardment would render any mission to explore these structures a catastrophic failure. The pillars of creation, therefore, stand as both a testament to the incredible beauty of the universe and a stark reminder of the immense dangers lurking within it. As we delve deeper into this cosmic juxtaposition, we encounter yet another celestial marvel whose beauty hides a perilous secret. As the next challenge unfolds, let us dive deeper into the devastating effects of radiation within the pillars of creation and the surrounding Eagle Nebula. Here, intense radiation doesn't just sculpt, it obliterates. High-energy ultraviolet and X-ray photons emitted by nearby massive stars tear through the delicate clouds of gas and dust, stripping electrons from atoms and leaving a trail of ionized particles in their wake. This process, known as photoionization, fundamentally alters the structure and stability of these cosmic pillars. Observations from advanced telescopes like the Hubble Space Telescope have revealed the eerie glow of ionized gas, a haunting signature of the destruction taking place. The extreme energy saturating this environment ensures that no spacecraft or material object can survive for long. Any attempt to send a probe or manned mission would be swiftly thwarted by relentless particle bombardment, which would overwhelm even the most sophisticated shielding technologies. Furthermore, the lethal levels of radiation would render any form of exploration near impossible, as the electronics vital for communication and navigation would almost instantly succumb to this high-energy environment. Despite its ethereal beauty, a beauty so magnificent it feels almost eternal, the Eagle Nebula and its radiative forces remind us of how unforgiving the universe can be. This juxtaposition between creation and destruction, between life-giving star nurseries and the same forces that doom them, paints a vivid picture of the intricate dance of cosmic evolution. And yet, the universe holds even more extreme environments where the very fabric of matter is tested to its limits. Moving forward, we encounter a true marvel and menace of the cosmos, the Neutron Star PSR J1748-2446ad, a record-breaking phenomenon and the fastest-spinning neutron star ever discovered. Neutron stars themselves are already staggering objects formed from the collapsed cores of massive stars that have undergone supernova explosions. What remains is an incredibly dense remnant, so compact that a single sugar cube-sized piece of its material would weigh as much as an entire mountain here on Earth. Now envision this ultra-dense object spinning at an incomprehensible rate of 716 times per second. To put this velocity into perspective, the star's equator is moving at a significant fraction of the speed of light, a speed that defies what we can truly comprehend. This rapid rotation creates staggering magnetic fields, trillions of times stronger than anything we experience on Earth, and these fields generate relentless beams of radiation that sweep through space like deadly cosmic lighthouses. The immense gravitational pull of such a star warps spacetime itself, and its surface is an unforgiving environment where matter is crushed under pressures we cannot begin to replicate. Any object venturing too close would face a fate far worse than destruction. It would be torn apart at the atomic level, and the deadly radiation emitted from the star would instantly annihilate any form of life or electronic systems, no matter the level of technological advancement. The existence of this neutron star challenges our understanding of physics, exposing us to forces and extremes that push the very boundaries of what matter can endure. Yet PSR J1748-2446ad is but one example of the unrelenting hostility the universe harbors, a chilling reminder that some of the most fascinating phenomena in space are also the most terrifying. What can possibly top a spinning giant like this? Let us venture further into the unknown, where the threats grow even more unimaginable. As the next challenge unfolds, we delve deeper into the unimaginable physics of neutron stars, where reality itself bends under the weight of their extremes. The gravity of a neutron star like PSR J1748-2446ad is so intense that it outstrips any force we experience on Earth. This gravity compresses matter into densities that boggle the mind. Just 1 teaspoon of its material would weigh as much as several billion tons. Such density warps space-time to the brink of collapse, creating an environment where the very laws of physics are pushed to their limits. Adding to this chaos is the star's relentless rotation. Spinning at 716 times per second, the centrifugal forces at its equator stretch and squeeze the star into a slightly flattened shape, while generating jets of radiation that are devastatingly powerful. These energy beams, known as pulsar emissions, are so intense they can light up vast regions of space, but their ferocity is also lethal. Anything caught in the path of these beams would be incinerated in an instant, as the radiation doses are far beyond anything life can withstand. Even the magnetic fields surrounding the star are on a scale so extreme they're almost incomprehensible, billions of times stronger than a typical magnetic field on Earth. These fields twist and distort particles in the vicinity, creating a maelstrom of deadly radiation that no technology or life form could ever survive. The rapid spin and intense gravitational forces also create a crushing environment on the neutron star's surface, where atoms are packed so tightly that they lose their individuality, merging into a sea of neutrons. It is a landscape completely alien to anything we know, a place where atoms and even the particles within them are crushed under pressures beyond human imagination. Neutron stars like PSR J1748-2446ad are not just remnants of stellar death. They are cosmic laboratories displaying the universe's most extreme and bizarre behaviors. The physics they reveal challenges what we know about matter, energy, and the very nature of existence. But if you think this is as dangerous as the universe gets, brace yourself as we journey into the extraordinary chaos that lies at the heart of our very own galaxy. Now turning to the most hellish planet in our solar system, we arrive at Venus, a world so hostile that it redefines the meaning of extreme. Venus may be similar in size and composition to Earth, but the resemblance ends there. Its surface is a blazing inferno, with temperatures soaring to over 800 degrees Fahrenheit, hot enough to melt lead. This unbearable heat is the result of a runaway greenhouse effect, as Venus's thick atmosphere, made up primarily of carbon dioxide, traps immense amounts of solar energy. Adding to the planet's hostility is its crushing atmospheric pressure, which is about 90 times greater than what we experience on Earth. To put that into perspective, it would be like being submerged nearly 1 mile deep in the ocean. And if that weren't enough, its atmosphere is laced with dense clouds of sulfuric acid, which rain down in a corrosive deluge that could dissolve metal. These factors combine to make Venus an undeniable death trap for any life as we know it. Early spacecraft sent to explore this unforgiving world, like the Soviet Venera missions, faced immense challenges. Many were destroyed almost immediately upon entering Venus's atmosphere due to the extreme heat and pressure, while those that managed to land survived for only a few minutes before succumbing to the planet's merciless conditions. Even the most advanced technology of the time was no match for this scorching, acidic wasteland. Venus is a grim reminder of how inhospitable planets can become under certain conditions, serving as both a chilling warning and a source of fascination for scientists studying planetary climates. But the journey doesn't stop here. Next, we explore the very mechanisms of destruction that shape the life and death of stars themselves. As the next challenge unfolds, let us delve further into Venus's thick atmosphere and the catastrophic runaway greenhouse effect that transformed it into the inferno we see today. Billions of years ago, Venus may have had conditions similar to Earth, potentially even oceans. However, its proximity to the Sun initiated a devastating chain reaction. The Sun's intense rays caused any water present to evaporate, filling the atmosphere with water vapor, a powerful greenhouse gas. This trapped more and more heat, which in turn caused even more evaporation, a relentless cycle that spiraled out of control. Over time, the water vapor was broken apart by solar radiation, destroying any chance of liquid water returning to the surface. Without oceans to absorb carbon dioxide, the gas accumulated in Venus's atmosphere, creating an oppressive blanket that locked in heat and left the planet unable to cool down. This runaway greenhouse effect sculpted the Venus we know today, a sweltering wasteland with a hostile atmosphere that serves as a sobering example of what happens when a planet's climate spirals unchecked. The implications for Earth are impossible to ignore. While our planet is vastly different from Venus, the lessons it offers are a stark reminder of how fragile our climate balance is. Scientists studying Venus use its extreme environment as a cautionary tale, emphasizing the importance of understanding and mitigating greenhouse gas emissions on Earth. By comparing Venus's atmosphere to our own, we can see how vital it is to keep global temperatures in check. These insights are critical for informing policies and technologies designed to address climate change here on Earth. Venus may be a world that is far out of reach, but its lesson strikes very close to home. Its story pushes us to think about the delicate equilibrium that makes life possible on our planet and the steps we must take to ensure it remains that way. But while Venus's fate is sealed, we now turn our attention to the life cycles of stars, where destruction takes on a cosmic scale through some of the most violent events in the universe. Now turning to the breathtaking yet terrifying phenomena of supernova, we find ourselves at the heart of the universe's most violent stellar events. A supernova occurs when a dying star reaches the end of its life in a spectacularly destructive explosion. Imagine a single star unleashing more energy in just a few weeks than our Sun could emit over its entire lifetime, a scale of power that is almost impossible to truly grasp. These colossal detonations send shockwaves rippling through space, obliterating anything in their path with unimaginable force. The intense burst of radiation that accompanies a supernova can strip away atmospheres from planets, incinerate nearby objects, and even affect systems that are light years away. But the destruction does not stop there. The explosion generates a wave of high-energy particles that races outward, sweeping up matter and leaving behind a trail of chaos in its wake. For any planet or spacecraft caught too close, the experience would be instant annihilation. Despite their catastrophic nature, supernovae play a crucial role in the universe by spreading elements like carbon, oxygen, and iron, the building blocks of life itself across galaxies. But for those in close proximity, the sheer ferocity of their energy is a stark reminder of the cosmos' destructive potential. These explosions, though beautiful and essential to the fabric of the universe, are among the most fearsome events known to exist, showing us just how small and fragile we are in the face of such cosmic power. With this devastating power in mind, let us now venture into an even deadlier consequence of stellar death: gamma-ray bursts. the universe's most intense beams of energy. Moving forward, gamma-ray bursts represent one of the most extreme and deadly consequences of a star's violent death. These bursts are the most intense beams of energy ever observed in the universe, capable of releasing more energy in just a few seconds than our Sun will emit over its entire 10-billion-year lifespan. Imagine a concentrated beam of radiation tearing through space at near light speed, obliterating anything in its path. If a gamma-ray burst were to occur relatively close to Earth and its deadly jet happened to be pointed directly at our planet, it could strip away the atmosphere, leaving Earth exposed to harmful cosmic radiation and fundamentally altering life as we know it, or eliminating it entirely. Scientists theorize that gamma-ray bursts might have been responsible for at least one mass extinction event in Earth's history, highlighting their potential to wreak havoc even across vast cosmic distances. These bursts are typically the result of a massive star collapsing into a black hole or neutron star, or from the collision of two neutron stars, creating an explosion of unimaginable proportions. The sheer energy of a gamma-ray burst is so overwhelming that even objects thousands of light-years away can still be affected by its radiation. Unlike supernovae, which release energy in all directions, gamma-ray bursts are focused into narrow jets, making their destructive power even more concentrated. This precision of destruction is what makes them one of the greatest cosmic threats known to science. Despite their terrifying potential, gamma-ray bursts also provide a glimpse into the universe's most extreme physics, offering scientists a chance to study the nature of energy, matter, and space-time under conditions that cannot be replicated anywhere else. These cosmic events remind us of both the immense power and the delicate balance that governs the universe. As we leave the devastating light of gamma-ray bursts behind, let us now turn to another terrifying phenomenon: black holes, whose event horizons represent the ultimate point of no return. Now turning to one of the most enigmatic and terrifying regions in the cosmos, we find ourselves at the event horizon of a black hole. This is the boundary where the gravitational pull becomes so intense that not even light can escape. As you approach this point of no return, the laws of physics as we know them begin to unravel. Time itself appears to slow, stretching seconds into what could feel like eternity. This mind-bending phenomenon, known as time dilation, means that someone observing from a safe distance would see you approaching the event horizon more and more slowly, as if frozen in time. But for anyone crossing this boundary, the reality is far more grim. The immense gravitational forces near a black hole create what scientists call spaghettification, a process where the difference in gravity between your head and your feet would stretch you into a long, thin strand of atoms. It is a gruesome demise, one that leaves no hope of return or survival. Black holes are formed from the remnants of massive stars that have undergone catastrophic collapse. Their cores are crushed into extraordinarily dense points, creating a gravitational pull so powerful that it warps the very fabric of space-time around them. Anything venturing too close is doomed to spiral inward beyond rescue to a fate unknown. The event horizon represents the ultimate boundary, where all information about anything that falls in is seemingly lost to the universe. Yet, this terrifying phenomenon remains one of the most fascinating mysteries in astrophysics. Scientists continue to study black holes to better understand how they operate, hoping to unlock some of the deepest secrets of the universe. As we peer into this abyss where gravity reigns supreme and the normal rules of reality cease to exist, we are reminded of the profound extremes the universe holds and how little we truly know about what lies beyond. With the next phase of the journey in sight, we venture deeper into the mysteries of the event horizon to speculate on what might lie beyond this enigmatic boundary. At its core is the singularity, a point where matter is believed to collapse into infinite density and where the known laws of physics completely break down. Imagine a place where gravity is so intense that not even the strongest theories in science can explain what happens. Some scientists suggest that the singularity represents a rift in spacetime itself, a region where space and time as we understand them cease to exist. Others hypothesize that it could act as a gateway to entirely different realms of the universe, or perhaps even to alternate dimensions, but the truth is no one knows for certain. To grasp the enormity of what we are discussing, think of squeezing an entire planet into the size of a marble. This is the kind of unimaginable compression we are dealing with. Theoretical physicists suggest that exotic concepts like quantum gravity might hold the key to understanding these extreme conditions, but until we can unite general relativity and quantum mechanics, the singularity remains one of the most perplexing challenges in science. Some posit that black holes could connect to so-called white holes, hypothetical regions that expel matter and energy rather than consuming it, forming what is sometimes referred to as a wormhole. This idea, while fascinating, exists purely in the realm of theory and has yet to find any observational evidence. The event horizon itself makes direct study nearly impossible, as nothing, not even information, escapes from within. This shroud of mystery is what makes black holes so captivating and yet so terrifying. What lies beyond their horizons remains one of the universe's greatest enigmas, a reminder of how much more there is to uncover about the cosmos. As we move forward from pondering the eternal unknowns of black holes, we set our sights on an entirely different kind of cosmic marvel, and one no less dangerous. Now turning to quasars, we arrive at one of the most extraordinary and perilous phenomena in the universe. Quasars are powered by supermassive black holes that actively consume matter at a staggering rate. As this matter spirals toward the black hole, it forms an accretion disk that heats up to millions of degrees, releasing an astonishing amount of energy. To put it into perspective, a single quasar can emit more energy than an entire galaxy filled with billions of stars. These cosmic beacons are so bright that they can be seen across vast distances in the universe, making them invaluable tools for astronomers studying the cosmos. However, their brilliance comes at a deadly cost. The energy emitted by quasars is not only extraordinarily intense but also incredibly destructive. Radiation from a quasar could obliterate anything unlucky enough to be in its path. The jets of high-energy particles they shoot out can stretch for millions of light years, tearing through the fabric of space and incinerating entire regions of interstellar material. Getting anywhere near a quasar would mean certain doom for any spacecraft or living organism. Despite their danger, these distant powerhouses offer a glimpse into the early universe, as the quasars we observe today are often billions of years old, providing a window into the universe's distant past. As awe-inspiring as they are, quasars remind us of the sheer power and unpredictability of the cosmos. As we marvel at their unparalleled brilliance, we prepare to journey into the cold, silent depths of space to examine a place that holds a very different kind of danger. Now turning to the cold depths of the cosmic microwave background, we enter a realm that is both hauntingly still and profoundly significant. The cosmic microwave background is the faint remnant of the Big Bang, a nearly uniform glow that permeates the entire universe. Temperatures here are unimaginably cold, hovering just above absolute zero, the theoretical point at which all molecular motion ceases. This makes it one of the most lifeless and inhospitable places imaginable. The emptiness and extreme cold create an environment where even the possibility of life or any meaningful activity is utterly non-existent. However, this frigid afterglow holds the key to understanding the origins of the universe. By studying the subtle variations in the cosmic microwave background, scientists can uncover clues about the universe's initial conditions, its rate of expansion, and even the distribution of matter and energy in its earliest moments. These faint ripples in the cosmic microwave background are like fingerprints of the cosmos, providing a snapshot of how everything we see today began. Despite its cold and desolate nature, the significance of the cosmic microwave background cannot be overstated. It serves as a reminder that even in the most silent and seemingly barren places, the secrets of existence itself can be found. As we leave behind this ancient glow, we now turn our gaze to the mysterious wanderers of the galaxy, the rogue planets, to uncover the dangers that come with a life untethered to a star. Now turning to the rogue planets, we encounter some of the most enigmatic and hostile objects in the universe. These planets drift through the galaxy unbound by any star, wandering in perpetual darkness. Without the warmth and light of a host star, rogue planets are frigid worlds where temperatures plummet to extremes that make even the coldest regions of our solar system seem mild. Their surfaces are cloaked in pitch-black darkness, concealing landscapes that could be frozen wastelands or barren, rocky terrains. The absence of sunlight means there is no energy to support life as we know it, and their isolation from the gravitational pull of a star leaves them adrift in the cosmic void. Despite these hostile conditions, rogue planets captivate astronomers because of the mysteries they hold. How do these planets form, and what forces eject them from their host star systems? Could some of them still harbor subsurface oceans or other conditions that might surprise us? These questions keep scientists eagerly searching for more of these dark wanderers, using advanced telescopes to track their faint signatures as they move silently through space. Rogue planets remind us that the universe is not only a place of wonder but also one of profound solitude, where worlds can exist in complete isolation, far from the life-giving energy of a star. As we delve deeper into the mystery of rogue planet origins, the story becomes even more compelling. Scientists believe that these planets may be born in the same way as traditional planets, forming from massive disks of gas and dust that surround young stars. However, a celestial tug-of-war can lead to their ejection. Gravitational interactions within their star systems, often involving larger planets or passing stars, may catapult these worlds into the vast expanse of space, leaving them to roam aimlessly. Another possibility is that rogue planets could form in isolation, failing to acquire enough material to become stars themselves. Once adrift, their journeys are fraught with peril, as they can collide with asteroids, comets, or even other planets during their silent voyage through the galaxy. Such collisions could create immense explosions, scattering debris across the cosmos and possibly disturbing nearby star systems. These wandering worlds also pose a unique threat if they venture close to other celestial objects, as their gravitational pull can disrupt orbits and even send smaller bodies spiraling into chaos. Despite this inherent danger, studying rogue planets might unlock secrets about planetary formation and the dynamic forces shaping our universe. Their unpredictable paths and violent histories make them as fascinating as they are fearsome, offering yet another glimpse into the breathtaking extremes of the cosmos. Now turning to what truly makes space so dangerous, let us explore the fundamental forces and phenomena that render these cosmic locations so perilous. At the core of nearly every danger in the universe lies the concept of extreme gravity. From the supermassive black holes devouring stars to the neutron stars with crushing densities, gravity is a relentless force that bends space, warps time, and spaghettifies anything caught in its grip. Its sheer power can stretch, compress, and obliterate matter in ways that defy comprehension. But gravity is just the beginning. Radiation, in its many lethal forms, stands as another universal threat. From intense gamma-ray bursts unleashed by exploding stars to the high-energy particle streams emitted by quasars and neutron stars, this invisible menace can fry anything in its path. Even our relatively mild sun produces solar radiation that poses risks to astronauts and spacecraft. Temperature extremes present yet another layer of cosmic hostility. In space, temperatures can soar to unimaginable heights near phenomena like supernovae and quasars, while plunging to near absolute zero in the vast voids between galaxies. This staggering range tests the limits of any material and makes survival an almost impossible challenge. Combining these forces, gravity, radiation, and temperature fluctuations, space becomes an unforgiving realm that pushes the boundaries of what life and technology can endure. Such extremes are a stark reminder of how small and fragile we are in the face of the cosmos, while also inspiring awe for the forces that shape the universe's most spectacular phenomena. Moving forward, let us dive into a question that sparks both curiosity and wonder. Could humans ever survive in these deadly places? The short answer is no, at least not with our current technology. Each of these cosmic environments presents challenges so extreme that they push the limits of human endurance and ingenuity. Take black holes, for example. The gravitational pull near their event horizons is so overwhelming that it would spaghettify any spacecraft, shredding it into atoms before it even reached the point of no return. Radiation is another insurmountable barrier. The gamma-ray bursts from supernova or the high-energy emissions from quasars would obliterate any shielding we currently have, turning any attempt at exploration into a fatal endeavor. Temperature extremes, from the blistering heat near a star to the freezing depths of a cosmic void, also make these locations intolerable. Even Venus, a planet within our own solar system, is far beyond what any human could withstand without significant advancements. Its crushing atmospheric pressure and corrosive sulfuric acid clouds make it an unlivable hellscape. Yet, human ambition has always defied impossibilities. Hypothetically, survival in such places would require monumental breakthroughs in science and engineering. For instance, a vessel exploring the vicinity of a black hole would need shielding strong enough to counteract radiation and gravitational forces, as well as life support systems capable of withstanding extreme conditions. Similarly, surviving the cold depths of a rogue planet would demand innovations in thermal insulation and energy generation, perhaps harnessing nuclear or fusion power. Even Venus could someday be visited through advanced robots or spacecraft designed to endure its intense heat and pressure, paving the way for potential exploration instead of direct human presence. While these scenarios might sound like science fiction, they highlight how far we still need to go in terms of understanding the universe and developing the tools to explore it safely. They also emphasize the resilience and creativity of the human spirit, continually striving to overcome the boundaries of the impossible. As we advance, one thing remains clear: space exploration will always be a testament to our drive to understand the cosmos, no matter how dangerous or inhospitable it may be. And with that, let us turn our focus to the breathtaking beauty hidden within this danger, a reminder that even in destruction, the universe can inspire awe. Now turning to the breathtaking beauty hidden within this destruction, let us reflect on how these perilous places are also some of the most mesmerizing phenomena in the universe. Black holes, for example, with their gravitational dominance that consumes everything in their path, are surrounded by magnificent displays of energy. The radiant accretion disks that form as matter spirals inward shine brighter than entire galaxies, offering a stunning contrast to the darkness within. Supernovae, though catastrophic, produce vivid explosions of color and light, scattering heavy elements into space and seeding the cosmos with the raw materials for new stars and planets. Even the searing surface of Venus, with its golden clouds of sulfuric acid, holds an eerie beauty when viewed from a safe distance, as sunlight reflects off its dense atmosphere in shimmering brilliance. The mystique of these deadly places is intricately tied to their danger. Their extremes of heat, cold, and radiation showcase the universe's ability to push the boundaries of nature itself. It is precisely this duality, their ability to terrify and captivate, that fuels humanity's fascination. We are drawn to understand how something so destructive can also be so awe-inspiring. The pillars of creation in the Eagle Nebula, while slowly eroding under intense radiation, remain an iconic example of the universe's artistry, towering like ancient sculptures carved by cosmic winds. Even quasars, with their deadly energy emissions, illuminate the distant reaches of space, allowing us to glimpse galaxies on the farthest edges of the observable universe. Perhaps it is this beauty, born from destruction, that drives humanity's enduring desire to explore the cosmos. Facing the dangers of these places not only challenges us but also inspires us to push our limits, to create new technologies, and to dream of understanding the universe's mysteries. Beauty and destruction are intertwined, revealing the boundless creativity of the cosmos and reminding us of our place within it. With such inspiration fueling our curiosity, let us now consider what we have learned from studying these incredible yet hostile regions. With the next phase of the journey in sight, let us delve into what scientists have uncovered by studying these perilous corners of the universe. From black holes to neutron stars and exploding supernovae, each of these phenomena has revealed crucial insights into the fundamental workings of the cosmos. Through the observation of black holes, for instance, researchers have gained a deeper understanding of how gravity behaves under extreme conditions. Theories of spacetime, famously described by Einstein, have been confirmed and expanded as scientists observe how light bends and time slows near these enigmatic giants. Similarly, supernovae have provided a clearer picture of stellar life cycles, showing how stars end their lives in spectacular explosions that spread essential elements like carbon and iron across the galaxy, elements that form the very building blocks of life. By studying neutron stars with their immense density and rapid rotation, scientists have unraveled key details about nuclear physics, particularly how matter behaves under pressures so intense they cannot be replicated on Earth. And when it comes to quasars, those dazzling beacons powered by supermassive black holes, scientists have used their incredible brightness to map the farthest reaches of the universe, peering back in time to study galaxies as they existed billions of years ago. Even Venus, with its hostile atmosphere and runaway greenhouse effect, has taught us valuable lessons about climate systems, helping us better understand our own planet's vulnerabilities and what must be done to preserve it. Each of these discoveries not only deepens our knowledge of the universe, but also helps us refine our tools and models for future exploration. With advanced telescopes and spacecraft, we continue to draw back the curtain on these dangerous yet revealing places, piecing together the story of how the universe came to be and what its future might hold. And as we uncover these secrets, questions arise that push the boundaries of human curiosity even further, setting the stage for the next wave of discoveries. Speaking of the tools that make such breakthroughs possible, let us now turn to the role of technology in unlocking the mysteries of these cosmic wonders. Now turning to the role of technology, it is impossible to overstate how advancements in telescopes, satellites, and space probes have revolutionized our ability to study these distant and dangerous places. Modern telescopes, both ground-based and space-based, have allowed us to peer deeper into the cosmos than ever before, capturing light from galaxies billions of years old and revealing intricate details of celestial phenomena that would otherwise remain hidden. Instruments like the James Webb Space Telescope have provided unprecedented clarity, allowing scientists to capture images and data that push the limits of our understanding, from the structure of exoplanetary atmospheres to the earliest moments after the Big Bang. On Earth, massive observatories such as those in Hawaii and Chile are outfitted with adaptive optics systems that compensate for the distortions caused by our atmosphere, producing images of distant stars and nebulae with striking precision. Moving beyond Earth's surface, satellites have become invaluable tools for observing high-energy cosmic events like gamma-ray bursts and supernovae, detecting phenomena that cannot penetrate our atmosphere. These orbiting instruments provide continuous monitoring of the universe, giving scientists real-time data and opening a window to phenomena occurring millions or even billions of light-years away. Space probes, on the other hand, have taken exploration to an entirely new level. Unmanned missions such as Voyager and New Horizons have ventured beyond our solar system, sending back invaluable data on planets, moons, and even interstellar space where the sun's influence finally wanes. One of the most awe-inspiring aspects of these technologies is their ability to gather information from hostile environments where no human could ever survive. From the crushing atmosphere of Venus to the icy depths of rogue planets, robotic missions are equipped to endure conditions that would obliterate most other forms of technology. They carry sophisticated instruments capable of analyzing radiation, magnetic fields, and particles, effectively acting as our eyes and ears in the most unforgiving corners of the universe. Equally important are the advancements in data processing and simulation technology. Supercomputers now enable scientists to model the behavior of black holes, simulate the violent explosions of stars, and even predict the evolution of entire galaxies over billions of years. These models are built on the data collected by our telescopes and spacecraft, converting raw observations into meaningful insights that help us grasp the complexities of the cosmos. With each leap forward in technology, we unlock another layer of the universe's mysteries. These tools not only fuel our curiosity, but also inspire the next generation of engineers and scientists to push the boundaries of what seems possible. As we marvel at what we have achieved, the horizon of discovery continues to expand, leaving us to wonder what breathtaking advancements may come next. And speaking of the future, let us imagine how upcoming missions and innovations will further transform our exploration of these extraordinary and perilous places. With the next phase of the journey in sight, let us speculate on the future of exploring deadly places in the universe. As technology continues to evolve, the possibilities for uncovering the secrets of these perilous regions become ever more exciting. Imagine spacecraft equipped with self-repairing materials that could withstand the immense pressures and temperatures of extreme environments like Venus or the surface of a neutron star. Future probes could utilize advanced artificial intelligence systems to make split-second decisions in environments too hostile or unpredictable for real-time human intervention. This would enable them to navigate through the turbulent radiation fields near pulsars or approach the event horizons of black holes to gather groundbreaking data. Another promising avenue lies in the development of new propulsion systems. Technologies such as nuclear fusion-powered engines or even the theoretical concept of warp drives could allow us to send spacecraft farther and faster than ever before. This would make it feasible to reach distant rogue planets, explore the vast emptiness of cosmic voids, or even study quasars in detail. These advancements could reduce travel time from centuries to mere decades, revolutionizing our ability to study distant corners of the cosmos. Additionally, advancements in miniaturization and robotics could lead to the creation of swarms of tiny, durable probes, each no larger than a coin. These devices could be sent in large numbers to hazardous environments, working collaboratively to collect and transmit data. For instance, a fleet of these microprobes could map the intricate magnetic fields around neutron stars or track the devastating radiation patterns of gamma-ray bursts, offering insights that a single spacecraft could never achieve. We could also see the rise of telescopes and observatories far beyond Earth's orbit. Imagine an array of space-based telescopes positioned at the edge of the solar system, free from the interference of sunlight, which could detect even the faintest signals from the most distant and dangerous places in the universe. Such instruments would offer new perspectives on phenomena like the formation of supermassive black holes or the initial conditions that led to the birth of the universe. Moreover, human exploration, while currently limited by the harshness of these environments, may not remain entirely out of reach. Technologies such as advanced exosuits, powered by breakthroughs in materials science, might one day allow astronauts to explore environments previously considered impossible to survive. Though still a distant dream, the idea of human explorers setting foot on rogue planets or skimming the edges of a black hole ignites the imagination and fuels the drive to innovate. Ultimately, the future of exploring these extraordinary and deadly places will depend on our ability to push scientific and technological boundaries further than ever before. Each new mission, each piece of technology, will not only provide answers but also uncover new questions, reminding us that the universe is as vast and mysterious as it is dangerous. As we press onward, the interplay between human creativity and the challenges of the cosmos will continue to shape the next era of exploration, bringing us closer to unraveling the greatest mysteries of existence. And speaking of mysteries, one has to wonder, are there even deadlier places in the universe that we have yet to discover? Now turning to the ultimate question, are there even deadlier places in the universe yet to be discovered? The universe, as immense as it is mysterious, stretches far beyond the reaches of our current technology and understanding. Every new discovery we make often leads to even more profound questions, reminding us just how little we truly know. Could there be phenomena so extreme, so incomprehensibly hostile, that they dwarf even the supermassive black holes, gamma-ray bursts, and rogue planets we have already encountered? Perhaps there are regions where the laws of physics break down even more radically than at the singularities of black holes, places where matter and energy behave in ways that defy everything we think we understand. Consider the possibility of hypernovas, rare, colossal explosions of stars that release energy on a scale many times greater than a typical supernova. These cosmic cataclysms could potentially create shockwaves so powerful that they leave entire star systems in ruin. Or imagine magnetars far stronger than any yet observed, their magnetic fields extending unimaginably vast distances and annihilating anything that wanders too close. Then there is the tantalizing notion of dark energy or dark matter anomalies, regions where these mysterious forces concentrate, warping space, time, and matter in ways entirely unknown to us. Could such places exist, utterly undetectable with our current instruments, yet shaping the universe in ways we have yet to comprehend? And what of other dimensions or parallel universes, theoretical realms suggested by some interpretations of quantum mechanics and string theory? If such dimensions exist, could there be rifts or gateways between them, zones where the properties of our familiar universe collide with entirely alien rules of existence? Such areas might represent the ultimate frontier of danger and mystery, where survival might not just be improbable but fundamentally impossible. Even within our own galaxy, there remain countless uncharted phenomena. For instance, scientists speculate about the existence of ancient, invisible black holes wandering the cosmic void, remnants of a time long before galaxies formed. These so-called primordial black holes could be smaller and harder to detect but no less deadly, lurking unseen until it is too late. The universe's sheer scale also raises the chilling prospect that some dangers are so rare or distant that we may never encounter them, or perhaps they are so vast that they operate on scales of time and space utterly alien to our comprehension. Could there be galaxy-wide events such as cosmic strings or domain walls, vast structures theorized to be remnants of the universe's earliest moments, capable of wreaking havoc on an unimaginable magnitude? Ultimately, the vastness of the cosmos ensures that its dangers are likely as infinite as its wonders. For every peril we have identified, there could be countless others, waiting in the shadowy corners of the universe yet to be explored. These questions fuel our drive to search, to push the boundaries of what is known, and to remain ever curious about the mysteries that await. And with this curiosity, we inch closer to understanding not only the dangers but also the beauty and complexity of the universe we call home. As the next phase of the journey unfolds, let's shift gears and entertain the idea of surviving these extreme places, not because it would ever be possible, but because it just might be fun to imagine. First off, if you are somehow heading into a black hole, your packing list would absolutely need to include a sturdy anti-spaghettification suit. While physics suggests no material could withstand the tidal forces, it's fun to wonder if some futuristic tech might keep you from being stretched into cosmic noodles. Now let's talk about dodging a gamma-ray burst. You'd need a spaceship with shielding so advanced it could repel energy equivalent to billions of exploding stars. Essentially, you'd be flying a fortress made of pure hand-wavium, because that's about the only material that could withstand that level of radiation. And if you were planning a sightseeing trip to the Boötes Void, you'd better bring along a good book or two, or maybe 1,000. The sheer emptiness and isolation could be mind-numbingly boring. Perhaps an artificial intelligence companion could help keep you entertained, though you'd have to ensure it doesn't develop existential dread from contemplating the void too long. Now, for a visit to Venus, forget sunscreen. You'd need an entire spaceship coated with acid-resistant material and capable of withstanding crushing pressures and temperatures hotter than your kitchen oven set to max. Basically, your survival plan would need to mimic a miniaturized fortress on wheels. As for avoiding magnetars, well, it's simple, just don't go anywhere near one. If you did, you'd need a magnetic field-proof suit, unfortunately. Science says that doesn't and probably never will exist. But hey, maybe in some wild science fiction future, humanity cracks the code of magnetar-proof technology. And if you ever found yourself venturing into the realm of rogue planets, you'd need a heating system powerful enough to turn an ice cube into a tropical beach while simultaneously conserving energy. After all, these planets are frigid, lifeless wanderers with zero sunlight to keep you warm. But the real survival tip, if you ever find yourself facing these cosmic nightmares, is simply this: stay home. The beauty of the universe can be admired just fine from a safe distance, and the wonders of modern astronomy give us all the thrills without the risk of being atomized by cosmic radiation or devoured by a black hole. Still, it's fun to imagine what gear you'd need to turn the most hostile places in the universe into the ultimate adventure. And with humanity's boundless creativity and curiosity, who knows? Maybe one day these hypothetical survival kits will become a reality. But for now, let's leave the exploring to our telescopes and keep dreaming of the stars. As we bring this cosmic journey to a close, it's astounding to reflect on the incredible places we've explored, each more awe-inspiring and terrifying than the last. From the eerie emptiness of the Boötes Void to the raging infernos of Venus, from the spinning death traps of neutron stars to the unfathomable mysteries of black holes, the universe reveals itself as a realm of extremes that challenge our imagination and our understanding of existence. These places are not just dangerous, they are a testament to the raw, unyielding power of the cosmos, reminding us of both its beauty and its brutality. So now, it's your turn. Which of these places left you most in awe or chilled you to the core? Share your thoughts in the comments below. Let's keep the conversation going about the wonders and mysteries of our universe. And if you enjoyed this journey through the cosmos, don't forget to like this video, subscribe to the channel, and tap that notification bell so you never miss out on our future dives into space exploration and the secrets of the universe. There's so much more out there to discover, and who knows what incredible mysteries we'll uncover next. Keep looking up and let your curiosity take you to the stars.